All right, well, welcome back. Hope everybody had a good 3-day weekend. You got a short week, but a really important item coming up on Thursday, your second exam. Okay, it's going to cover three main topics. It's going to have the graphing rationals, just like the quiz we had last Thursday. Okay, you're going to have to sketch it, find me the intercepts, find me the asymptotes, all that good information. Then you're going to have a rational equation problem, very similar to this focus activity, and you're going to have a rational inequality problem, very similar to the exit ticket that we just did. All right, now I was just talking about resources. Yesterday, while I was in content focus session, if you come on over to the website, you'll notice in the current week right here, solving rational equations, you've got a lot of equations with the answers. Now, it doesn't show you the steps, so if you have questions, you can come on in and ask me. I did go ahead and put a graphing rational functions practice on there. There's 20 problems, and there's the graphs that follow. Okay, so you have all that information. And yesterday, I did go ahead and put a solving rational inequalities document on there. So this one actually provides not only more practice, but actually walks you through the concept. So any of those, if you are looking for more practice, that is available on the website. Okay. One other thing I want to go ahead and mention is that at code up there at the top. I think some people were absent last week when I first brought this up, and then I just completely forgot to mention it again. But I did create a Remind 101. Okay, for this class, in fact, for all my classes. So if you would like to sign up to receive text messages from me in addition to the Google Classroom, at 6G9DF3. So I'll probably go ahead and text you, before a major exam or quizzes, things like that, just to let you know anything very quickly. Maybe I forgot to mention in class. The other thing that I want to go ahead and mention is, remember, this Friday by 8:05 is the deadline to retake the graphing rationals quiz from last Thursday. But what's the catch? You have to have the assignment done. I got a lot of folks who still don't have it done. You are able to retake. You just have to turn in the assignment. Now, the same thing's going to apply to this test on Thursday. You can't retake the test unless you have that assignment and the rational inequalities assignment we turned in Friday as well. So speaking of, if you haven't turned in the rational inequalities and you've got it, please go ahead and turn it in. The sooner the better. I can get it turned back to you and you can use it to study tomorrow night. But what is next Friday? It is the end of the first 6 weeks. We are already going to be done. So I'll be calculating the grades and submitting them. All right, so please keep this in mind. Our time is running out very, very quickly. Now, at the beginning of the school year, I said I didn't have anything in place, kind of like as an incentive or motivation, for things in class. And it's not so much in class. I'm noticing we're not getting a lot of homework turned in. So I thought, what can I do to try and get some more homework assignments turned in and also help people who need to retake? Well, you know how I put the categories in the grade book at a 0% level so that I can just keep track of them? Okay, I'm going to go ahead and do the same thing, but I'm going to go ahead and create a category that's called probably something like bank points, or maybe point bank, something like that. So basically, every time you turn a homework assignment in on time, I'm going to put a certain number of points in that bank. Now, you can use those points at any time for test, for a quiz, any grade that you did a little lower on. Okay, maybe on one of those, you can retake up to an 80 if you happen to get maybe a 77 or a 76 and you got points in your bank. That'll pull you up to an 80. You don't have to worry about the retake. Now, I'm only going to start it on this current assignment, the one that's due Friday, this difference quotient right here. But just kind of think, we have potentially, we could potentially have 6 homework grades that we turned in this 6 weeks alone. If I were going to go ahead and take them at 3 points each, that could be 18 points in a 6 weeks you'd be putting on a test, a quiz, whatever. All right, so if you are kind of worried about maybe the quiz from last week, or if you're looking into the test this coming Thursday, that is what I thought about doing. What do you guys think? Having point bank. Now, they're only good for a 6 weeks, okay? So, and maximum would be 110. I'm not going to go over 110. That's ridiculous. And they don't carry over to the next 6 weeks. Okay, so whatever you turn in for 6 weeks will help you out. All right, so on any one grade. That's the highest I'm willing to go. Yeah, normally I go 105, but it's conceivable that I have people who are already acing everything and already have maxed themselves out. So I'll go ahead and push it to 110 to kind of help those folks out. So, all right, any questions about any of that I brought up? Okay, well, let's take a look at number one here. Solve the rational equation. X over 5x plus 5 equals 1 over x plus 2 plus 1 over x squared plus 3x plus 2. Well, let's see here. We have several strategies we could use. We could simply multiply through by the common denominator. Okay, just go ahead and get rid of all the fractions. We could go ahead and rewrite every fraction, make sure they have the same denominator, essentially make them equivalent fractions, and then pull the equation from the numerator. We could go ahead and just add the two fractions on the right and create a proportion. Okay, and that's not even the only three methods we have. There are many more. But what sounds good to you guys? So far, periods 1 and 2 have already chosen different strategies. What would you guys prefer? The first one? So we just want to multiply through by the LCD. Proportion. Okay, let's take the proportion. No one's taken that one so far. So I'm going to go ahead and break this up. X over 5 times x plus 1. Okay. Now this over here, let's go ahead and break this guy. Now x plus 2 is prime, but what would the factored version of the trinomial there be? X plus 2, x plus 3. So what I'm looking for here is just to combine the two fractions on the right. And maybe since I'm doing this, I probably want to keep the other denominator together, but I'll fix that in just a second. So the two fractions on the right, Philip. Oh, is it x plus 1? I'm sorry. I was looking at that 3 right there. There we go. X plus 2, x plus 1. Okay. So what would the common denominator on the right side be? It would be x plus 2, x plus 1. So 1 over x plus 2. Okay. Well, I'm missing the x plus 1. Okay. Plus 1 over the x plus 2, x plus 1. All right. So I'm going to go ahead and recombine these over here. So x over 5x plus 5, since we're not looking at all of them. All right, so do you want me to go ahead and take one additional step before I combine these, or can I go ahead and combine them right now? Natalia, what do you think?
You can just combine.
Just go ahead and combine them right now. So because I'm looking to solve this with a proportion, I'm going to go ahead and multiply these guys together. All right, well, we already know that's x squared plus 3x plus 2. Okay. Now, what would I get in the numerator of the single ratio? It would be x plus 2. Everybody okay with that? Okay. So now what? What do? How do you solve a proportion? Cross multiply. All right. So let's see here. I want to multiply 5x plus 5 times x plus 2, which will give me, let's see, 5x squared. What is that? Plus 10, plus 15x? Plus 15x plus 10 equals. Now I want to distribute x across that trinomial. Oh. Did I put 10x here? No. 5 times 2 give me 10. Did I make a mistake? It would be 15x. 5x times 2 plus 5 times x, right? Yeah? Okay. Took me a second. It's very possible I could make a mistake. Equals. So what do I get when I take the product of the other diagonal? X cubed plus 3x squared plus 2x. There we go. We got it. All right. So it looks like I got a cubic. And now it's just a matter of finding out what values make it true statements. Now, let's go ahead and combine my like terms. Let's get everything to one side. So I'm going to leave the x cubed where he is. If I go ahead and subtract the 5x squared over, minus 2x squared. Okay. Then I'm going to subtract the 15x over. minus 13x, and then it looks like I'm going to have minus 10 is equal to 0. All right. Questions? Now this one here, it's a great strategy. Hopefully a lot of people remember how we can break apart a cubic. A good strategy if you have 4 terms like this is going to be grouping, but right offhand looking at it, I'm not seeing a whole lot of help there, which means we're going to have to focus on the factors of 10. Okay, so what are all the factors of 10? Okay, so we got 1, 2, 5, and 10 itself. But then we want to look at both plus and minus of each of those. Okay. So basically, we're going to go ahead and use synthetic division on this guy. We just have to choose one of the 8 values we have right here. Okay. Does everybody see what I'm referring to? Okay. Now, at most, this guy's going to cross the x-axis how many times? Okay, at most he could cross 3, guaranteed he has to cross at least once. Okay, because remember cubics, they're down on one side, but they're up on the other. Do you guys remember that from Algebra 2? Okay. Well, I'm just going to go ahead and kind of mainstream this thing. I'm going to go ahead and give you one that works. All right. 5 is a solution to this guy. So I'm going to start there just because you know of our time limit. But potentially, I mean, you could be choosing random numbers and they just might not work until you get lucky. So I'm going to go ahead and put the values to the right. 1, -2, -13, -10. Now, what am I looking for here? How would I know that 5 is going to be right? The remainder should be 0. There you go. I'm looking for a factor. Okay, so I'm going to drop this 1 right here. So 5 times 1 is 5, plus -2. 3 times 5 is 15, minus 13. 2 times 5 will give me 10. We did get a remainder of 0. Okay. So this guy worked out nicely. All right. So I know that I can take this cubic and I can go ahead and break it into x minus 5 because we had 5 as a root. Okay, we know that's a solution. And then we've also got this one here, which would be what? X squared plus 3x plus 2. Okay. And then we should be able to easily factor that trinomial that's left. Okay, good, good, good. So I've got x minus 5 times, this one's going to be x plus 2, x plus 1. There we go. So I was able to completely factor that cubic function. Is everybody with me? Okay. Well, how's that going to help me figure out my solutions? Set each of them equal to 0, and then go ahead and solve. So if x minus 5 equals 0, x equals 5. If x plus 2 equals 0, x equals -2. And if x plus 1 equals 0, x equals -1. Okay. Now, here's the thing. We still need to make sure that these are real solutions. What do we call it if I were to take one of these, plugged it back into the original equation, and it didn't work? Remember, we call that extraneous. Does one of them immediately look like it has to be thrown out? The -2. See, the -2, okay, if I went ahead and plug in -2 for each of these x's, I really only need to focus on this one right here, because that's going to make the middle fraction 1 over 0. I don't even need to finish that. I can already tell -2 is not a solution to the problem. Okay, so he is extraneous. Okay. Also, is there another one that's extraneous? It is -1. If you're to plug -1 in, it's not going to be a solution. But I do want to go ahead and show you how 5 is the only solution we're going to have. Okay, so why don't we go ahead and plug him in. Let me do this over here where I have a little room. So that would be 5 over 5 times 5 plus 5, 30. So I'm going to simplify that in just a second. Equals 1 over 5 plus 2, so 1/7, plus 1 over 5 squared plus 3 times 5 plus 2. 42. Answer to life, the universe, and everything. How many people know what I'm referring to? Okay, if you're raising your hand, you're a cool person. I mean, the other people are cool, they're just not as cool. So, okay. All right, now let's see. 5/30 is 1/6. I'm going to need a common denominator, which is 42. So I'm going to multiply by 6 over 6. So let's see, I'm going to end up, I'll just go ahead and write it out. That'd be 6 40-seconds plus 1 40-second. So 1/6 does equal 7 40-seconds. There you go. Again, I'm not going to worry about the -1. It is not going to work if you were to plug it in, just for the sake of time. But you always want to check your answers. Okay. So who was it? Galen, who said you wanted to do the proportion? That was a great method. Great method. Every class so far has chosen a different method today. Good. Any questions on this one? Okay. So you're going to find one of these on the exam as well. Okay. Perfect, perfect, perfect. Okay. Well, with the time we have remaining, I want to go ahead and introduce the difference quotient, which is your method of finding a derivative. Now, this is a pure calculus lesson. I do have an assignment that I gave you. It's just due when? It's going to be due on Friday. In fact, this is going to be the first assignment towards the point bank that I referred to a few moments ago. All right, so let's see how far we can get. More than likely, I'm probably just going to be able to derive the difference quotient, and then we'll work some examples during class tomorrow. This will not be on the test. Okay, this is not on the test. Okay, for a function f, the formula is f of x plus h minus f of x divided by h. This formula computes the slope of a secant line through 2 points on the graph of f. These are 2 points with x-coordinates x and x plus h. We then take the limit as h approaches 0 of the function f. Now, the difference quotient is used in the definition of the derivative, which allows us to find the slope of the tangent line at a particular value of x. Now, there are a ton of applications for these. In fact, if you're in physics class, the first derivative of a function will give you what? Starts with a v. Who are my physics students? Okay, Kaushal, I'm looking at you. The first derivative will give me what? Velocity. Okay. The second derivative will give me, starts with the A. Acceleration. There we go. So there are applications. What I'm going to do in here, I'm not even going to talk about the shortcuts. This is the universal method for finding the derivative of a function. I just want to make sure you've seen this before you get to Mr. Heinrich next year, where you're going to be using it a lot. Okay, so let's derive how we get this guy right here. First off, let's say I have some kind of function, maybe like this. Let's call it function f. All right. Now, the paragraph above mentions 2 types of lines, a secant line and a tangent line. Remember, a secant line is going to have 2 points of intersection. How many points of intersection will a tangent line have? Just the one. Okay. So let's identify a couple of points on this curve here. So let's say I have some value of x on the axis. So the corresponding value for that point would be x, f of x. Because the function is f, right? Remember, we use that function notation to kind of talk about the relationship between elements in the domain and elements in the range. If I plug x into the function, whatever operations are present there, it's going to manipulate the x. I'm going to get a y out of it. Okay. Well, let's say I want to compare this to another value of x further down the x-axis. Let's say the distance between these two x's is h. Let's say it has a horizontal distance of h units. So the x value here would be x plus h. Does that make sense? Because we're talking about 2 different values on the x-axis. Okay, so let's go ahead and figure out what the corresponding y value would be at that location. I know the x is x plus h. What would the y value be? Okay, Andrew says f of x plus h. There you go. See, for the first one, if I simply have x, I'm going to plug it into the function to get my y value. Well, if my new x is x plus h, I'm going to plug that into the function to get the y value that corresponds to that specific x. Okay. Well, this is where the secant line comes from, because I have 2 points of intersection. There we go. Let's say I want to find the slope of that secant line. Okay. What's the slope of a straight line? Does anybody remember the formula? Y equals x. Well, that's the linear parent, but that's not slope. There you go. It's y2 minus y1 over x2 minus x1. You remember the change in y over the change in x? Okay. Y2 minus y1 over x2 minus x1. Well, let's say that this point right here, x plus h, f of x plus h, let's say that's x2, y2. So I'm going to use these 2 points and apply it to my slope formula. So I'm going to say f of x plus h, that's y2, minus y1, f of x, over. Now I want the difference of the x's. Okay, but once you've chosen the direction, you got to go in the same direction. So I'm going to say x plus h, what? Minus x. So difference of the y's divided by the difference of the x's. That's what we've also come to know as rise over run, right? But do you notice anything about that denominator? Yeah, x minus x, those guys are just going to cancel. Okay, so I'm left with f of x plus h minus f of x all over h, which is exactly what we started at the very beginning. What's really nice about this, one of the most powerful ideas we have in calculus, the derivative, is based upon the simplest idea in algebra, the slope. Now, I'm not going to worry about, like I said, applications. I'm not going to be showing you the shortcuts. The more of these you do, you're going to start to pick up on what those shortcuts are. But that is for Mr. Heinrich to show you. We're simply going to be working with the algebra of this. Now, there's something I haven't mentioned yet. We said that we wanted to get the slope of a what? The slope of a tangent line. Well, right now we only have a secant line. So imagine that this graph were tangible, that I could actually grab this point right here and I could slide him along the function until I get to the other point. Well, if I were to do that, if I were to take this point and just start moving him along the graph until they get closer and closer, what's going to happen to that horizontal distance? What's that, Connor? He's going to eventually reach 0. He's going to become smaller the closer they get. That's why after we perform the algebra, we take the limit as h approaches 0. Because let's say we go ahead and get to a point where they do merge, that's when I have a tangent line. Okay? That's what the derivative is going to do. It's an expression that will, given any value of x, give you the slope at that location. Because if you have a curve like this, okay, at this value of x right here, if I were to choose another one like right here, what are you noticing? Okay, will the slope remain constant as I move through the graph? No, it's constantly changing because this is not a linear function. Okay, so that's what the derivative can do for me. It'll find me the slope at any value of x that I choose. All right, so that's the derivation. That's how we end up with this guy right here. So like I thought, we weren't going to make any examples, and that's fine. Okay, if you're hazy on this, if it's not making a whole lot of sense, that's okay. We just started it. We got the whole class tomorrow. We'll practice it. Okay. Once we start doing some examples, I think that'll help to make things a little more concrete. All right. So let's go ahead and stop there. Thank you very much, guys. Good job as always.